Thank you, Ava. Okay, thank you. Appreciate that. It is unfortunate that Dale couldn't be here with us, and I really wish that he could be giving this. And when Dale and I dusted off the abstract a month ago that we had sent in last fall, we looked at that 100 years and said, what were we thinking? So this is going to be a whirlwind going through this, and I'm going to touch the highlights along the way. I'm not going to be able to spend very much time in any one spot, but there's going to be a lot of people in the room sharing other things. But here we go, the Aspen story. And so the outline is that we're going to touch briefly on, and I've been in touch with Dale every day this week, and we've been still working back and forth, talked with him this morning. We're going to touch on Aspen biology and ecology, and then we're going to kind of break this into 4 different eras that we'll briefly touch on. The 1912 through the 1950s, the 60s through the 80s, and we'll focus on the work that was done at the Forest Service's Aspen project in Logan, the research work unit there. Then we'll spend some time in the 90s to present, go over some recent literature and applications, and especially things happening at the landscape scale. Take a look at Aspen's future in the western U.S., kind of do some speculating there maybe, and a little summary. Do really appreciate all of you being here, and it's fascinating to see the kind of energy that continues to revolve around. Populus tremuloides, that tremuloides, that trembling leaf when the wind blows. That's the result of that flat petiole, and people are fascinated with the quaking. It's also that flat petiole, if you have a late spring frost that and the leaf isn't fully hardened off, that's one of the most susceptible spots, and that petiole freeze and twist, and you can have near defoliation of the tree right at that flat petiole. Aspen regenerates from roots and root sprouts. We call them suckers often, and that is recognized as a technical term. There are also opportunities for this species to reproduce by seed, and it opens up a whole new world of genetics that Karen and her students will talk about here, and others that have an opportunity to do that. It's a fire-adapted species, but it's not fire-dependent. And it can do quite well in areas without the fire, and you can have multiple age classes of stems coming up. It is the widest distributed tree species in North America. Think about that in itself. From Alaska to Newfoundland, from Mexico to Canada, it's amazing the area that it covers, this ecological amplitude. In a local area, we see that ecological amplitude expressed elevationally. It can be down growing with the juniper. It can be up above the spruce and subalpine fir at the alpine areas. When we think Aspen, we're thinking the entire community. Sometimes people think we're just talking about the tree. But for pretty much the rest of my discussion, if you could be thinking what's going on in that entire community that's associated with it, tremendously rich biodiversity, micro and macro flora and fauna. Aspen is a keystone species that allows these communities to continue and to be sustainable. Tremendous clonal variation in a lot of different respects. And there's also tremendous community variation. Walt Mugler found over 50 different aspen community types in the Intermountain region. So here's some of the distribution. And as Dale was providing this information, he puts a note down at the bottom. To some, this implies insignificant amounts of aspen to worry about. There are places where it's in minimal abundance, and yet it's extremely important in those areas for the associated biodiversity. It's critical that we understand ways that we can sustain those areas. Some of the photos that we have aren't the best quality. Some of them go back as old as we are. And the one on the left comes from the Grove of the Aspen Giants on the Manti La Salle, the Wasatch Plateau. And that's roughly 40 or 50 miles north of I-70 and 40 or 50 miles east of I-15. It's just kind of right smack in the middle of the state of Utah. This is an important area. We'll touch on this in a few minutes. But the whole Wasatch Plateau. You'll notice a field assistant right there. Those trees, when we measured them in '82, 43 inches DBH, 95 feet tall excurrent growth. They're not there anymore. They've toppled and gone. The one on the right is over east of Monticello. For whatever reason, the terminal got nipped early on, and that tree branched out. I show this because this area across central Utah and into western Colorado is probably the area of optimum aspen growth. It's the latitude of optimum aspen growth. And as you go further north or south, you may not see the same kinds of growth patterns that you can through this area. And because of my point of reference and the information that we have and kind of where this aspen story started, a lot of my comments will kind of come from that area. But we realize that aspen, where it occurs in all the western states, and each of the western states where it is, that it's not one size fits all. There is tremendous variation in situations from state to state to state. And specifically, we understand that there are great differences in the abundance and the appreciation, the management, the location of the aspen stands, even between Colorado and Utah. Asexual regeneration. You can have all kinds of sprouts, suckers coming from a little segment of root, and it exhibits a polarity there. They'll typically come up on the proximal half of whatever root length you have there. How many have heard of the Pando clone? A few. It's located in the Fish Lake National Forest and Fish Lake Basin. There was a postage stamp a few years ago devoted to this Pando clone with this writing. The root system of a quaking aspen tree can produce a clone that appears to be an entire grove. A clone in Utah named Pando, Latin for I spread, weighs an estimated 6,600 tons, making it one of the most massive organisms known. Just the fact that this particular stand got named is amazing how much attention that has brought. Is there any way to get rid of that little clock up there or not?
You can move it down, maybe.
Maybe if it's... There you go.
Yeah, just stick it back there.
Great. Thanks, Ava.
Thanks.
So this is an example of seedlings from the Yancey area in Yellowstone, following the Yellowstone fire. Charles K. took this photo. Over 1 million seedlings per acre. And as far as we know, none of them survived. When the waters came up, they were either flooded or eaten by animals. Okay, so you can have upland pure aspen communities, stable aspen communities. some different examples. You can have snow pocket aspen, which can also be a stable aspen, Krumholz aspen, a stable aspen community. When I think of Krumholz, I think of it being up on a ridge top. This is actually in a little depression on a high ridge in the Sierras, as Dale explains to me. You can have an upland aspen conifer mix, where it's quickly moving from cereal aspen communities to conifer without some. You have riparian aspen, and again, it can be a cereal aspen. Charles Kay has these two photos from Bee Lake on the Dixie National Forest in southern Utah that can demonstrate the decline of aspen with time. 1872 from the Powell expedition, and same area 1996, where the conifer beginning to come in and suppress the performance. We've heard about sudden aspen decline more recently, and we have situations where we have overstories rapidly declining. This one, Dale indicates, has successful regeneration in it. Oftentimes, the definition of sudden aspen decline was that you have the mortality of the canopy without any regeneration coming up afterwards. This is a situation of sudden aspen decline on Cedar Mountain, east of Cedar City in southern Utah. The area looked like in 1990, and it was starting to show some differences there, and then in 2002. Pretty well isolated to that one clone in this. Fire is frequently associated with aspen stands. Dixie heat is what we call this photo in southern Utah. It was a prescribed fire. They knew exactly what they were doing, and it went off just fine. Brian Ferguson was the FMO there, the silviculturist, excuse me. Kim Soper was the FMO, Brian Ferguson was the silviculturist and later became the regional silviculturist. Brian had people contacting him asking him if he could use this photo, if they could use this photo to talk about the hazards of wildfire. He said, absolutely not. It's a prescribed fire. We'll mention some of the grindstone flat exposures in 1995, and then during the Pole Creek fire in 1996, 1975. That photo was taken in 1996. And I'll make some reference to grindstone along the way here. It's actually started in 1935. This can be used to indicate fires in asbestos type. That Pole Creek fire in 96 burned that pole fence down all the way around the aspen, but it did not go into the aspen stand that was 60 years old. So a little bit after the format of Ray Haddo in the plenary session, I'm going to step away from the PowerPoint and Ava suggested we will highlight these, combining this, and there's thousands of Aspen articles. Just because it made this page or didn't make this page, not meant to be judgmental in any way, but some of these are some of the really critical publications of Aspen, the synthesis. And there are others that are kind of obscure. But given the technology that we have, go out on Google and find a lot of these. And you might little Leopold story. In 1935, Alda Leopold was on a trip in Germany, and he wrote on a napkin at on the back of some hotel stationery. One of the anomalies of modern ecology that it is the creation of two groups, each of which seems barely aware of the existence of the other. The one studies the human community almost as if it were a separate entity and calls its findings sociology, economics, and history. The other studies the plant and animal community and comfortably relegates the hodgepodge of politics to the liberal arts. The inevitable fusion of these two lines of thought will perhaps constitute the outstanding advance of the present century. I think there's a lot to think about there. And as I go through this, you'll understand that although we're talking some about the Aspen, I think it's really important that we start thinking a whole lot more about the social economic aspects of doing what we can to help manage these areas in a sustainable way. As I go through these decades quickly, these areas, I'm going to touch on a few themes. Regeneration and reproduction, vegetative sprouting and seeding, ungulate browsing and exposures, Aspen and Aspen communities, fire and fire histories, and such threats as disease, insects, sad climate change, old age, things like that. The experiment station was started up on the Wasatch where I grew up the Aspen Giants picture came from. When I say just north, maybe 20 miles north or so. 1912. A paper in 1919 by Arthur Sampson. The computer absolutely helps me, but I don't have the skill set to deal with it. So this is my illustration. I could not work these photos into the PowerPoint, given what I had. But I'll just tell you that in 1912, when they started, they went to that mountain. Frederick Baker was the fourth examiner, and they started clear cutting aspen, and they were figuring out how they could manage the aspen ecosystems. And this is a picture in 1913 of a pole fence sheep exposure. And they understood that if they were to get aspen regeneration, they needed to protect it from the sheep. And here's some examples here of aspen trees that were exposed to sheep. They did feel that they could get enough regeneration up that it would withstand the livestock grazing. They also noted that rodents were feeding on hurling some of the aspen. So 100 years ago, this year, they understood about aspen being eaten by animals. And it's kind of interesting to follow that. Baker writes this in 1918. The most striking fact brought out so far is the weakness of the seed reproduction of the tree in contrast to its great sprouting ability. A study of aspen seed was made to discover, if possible, the reason for lack of seedlings. In 1913, 1914, 1915, no seed all could be found. In fact, no pistillate catkins were seen, although salmon and flowers were found abundantly in scattered localized areas. He also writes, sheep must, to assure successful regeneration, be excluded from aspen areas 3 years after cutting, although moderate cattle grazing is permissible. It is accordingly evident from a silvicultural viewpoint that aspen is a very desirable species since its management is simple and reproduction certain. Adequate protection from sheep grazing. 1918. In 1921, Baker gives us a clue where we think about clones. And he's talking about the exceptional, how aspen is an exceptionally common tree at the middle elevations, covering large areas with solid bodies of pure type. In the spring, when the leaves are unfolding, it is commonly noted that the leafing time of adjacent bodies is quite dissimilar. Not infrequently, a line can be traced for upwards of a mile through the aspen where one side of the leaves are half developed and on the other, buds are just bursting. The writer confesses an entire inability to explain the cause of these two widely distributed but distinct and closely intermingled races of aspen. So they're thinking that they had two different races going on there. A great work by Baker in 1925 gives us a clue of some of the things that they were thinking about. They talked about how fire was very typical in this area on the Wasatch Plateau, and they had fire-scarred aspen. Fire-scarred aspen, they told a study about that. And fire returns of 7 to 10 years in some of these areas. Said a 50-year fire rotation would probably keep conifer entirely out of all the aspen type, except on the north slopes or in moist localities favorable to rapid development of coniferous trees. But they were already recognizing that the fire patterns had changed at that point. He also says with reproduction, there is practically no production of seed by aspen, at least not in Utah. This method of reproduction is of no importance in the management of aspen stands in the state. Suckering from the roots is the method by which regeneration takes place. And he also described that even age aspen stands, it was unusual to find trees over 40 years of age. Much younger stands. Okay, we're jumping ahead now into Houston's paper, 1954. Because of the importance of aspen, and he's writing a condition guide for aspen ranges of Utah, Nevada, southern Idaho, and western Wyoming. Because of the importance of aspen ranges for grazing, range managers are particularly interested in recognizing condition and summary and trend on them. And then they're using aspen as an indicator of range condition. If little reproduction is present and it can be determined that it is absent due solely to grazing, then this absence is an indicator of unsatisfactory range condition. If the absence of reproduction is not due to grazing or abundant reproduction is present, then no apparent condition class is indicated. I'm drawing 3 sentences out of an entire paper, so be careful what you're reading. Okay, here's Houston and, there's 2 different pronunciations of the same name, Houston and Houston. Here's Houston and Lincoln Ellison, 1958. Extensive forest of flaking aspen, which occur widely in intermediate elevations in the Intermountain West, constitute an important source both aesthetically and economically. The aspen type is esteemed among sightseers, picnickers, and campers because of its beauty. Aspen forests protect the soil of an important snow collecting belt on western mountain watersheds. Although the aspen is not of an important timber species, not one of the important timber species, aspen wood products are considerable and increasing demand. Finally, the type supports undergrowth capable of furnishing a great amount of cover and forage for wildlife and livestock. On aspen ranges in good condition, one may wade waist deep through rich mixtures of many plants. So the Houston and Ellison work begin focusing on the significance of the entire communities. Coming forward to 1972, here's a in Utah study with the Wildlife Department on aspen regeneration, and they conclude this at the end. Consequently, we cannot compare the relative effects of deer and livestock under comparable intensities of use. Nothing in our data suggests that regeneration of aspen is not possible even under heavy use by domestic livestock. And so they were not finding pressure there. Now we get to Templeman and Barnes, 1976. This is a small on the corner. This is where they delineate the boundary of a stand of Aspen in the Fish Lake Basin. It's 107 acres in size, 47,000 ramets. And they called it a single clone. And they also say in this paper that this area has other clones in southern Utah and into Colorado over 200 acres in size. We don't know where they had those, but this one was close to get to, and this is the one that. So this is where the source document where Pando first hits the print. It wasn't called Pando then, but that's what it came from. Then Walt Mugler and Dale Bartos had a paper that looked at the grindstone flats exposures, and they said, we believe that successful regeneration of aspen on clear cuts or burns may be dependent upon the size of the area treated, unless deer and livestock can be rigidly controlled. Without control, ungulate use, clear burning less than about 5 hectares of mature aspen might be futile. Even if livestock are excluded from such areas for fire, they concentrate on small treated areas and prevent the escape of sprouts. So there was beginning to be a recognition of maybe having treatments be a larger size. In this same period that we're in right now, there was an aspen research set up in Logan, Utah. Dr. Bill Lakehawk was the first project leader of that project, 1968. And it's great to have you here with us, Bill. And that project went on for about 16 years. Bill had it until 1974, and then Walt Mugler came in as project leader and was there until about 1983. Walt was there longer, but that's when the project was disbanded. Bill gave it a great start. Walt was tremendous in following up. Walt did aspen classifications. The Intermountain region, over 50 types of aspen community types. Walt McDonald, one of the scientists on the project, found that aspen in the west produce ample amounts of non-dormant germinable seed. However, inadequate soil moisture during germination and early seedling growth usually prevent establishment under field conditions. And given the right temperatures, moisture, germination can begin in 8 to 12 hours. I've collected aspen seedlings, aspen seed in Logan Canyon, put them on filter paper and petri dishes, seedlings 24 hours later. It is possible to store the seed in cold storage and have it retain over 80% viability for up to 4 years. A quote from Barnes 75, seedlings are much more common here fresh in fresh clear cuts and fertile sites. Nevertheless, seedling aspen, although rare, have been recorded in Utah by Ellison, Larson, and others. Another point to keep in mind in this time period, well, let me just mention that George Shearer on the project in Logan was involved with clonal variation, vegetative regeneration, and propagation. And George used to say to me, Bob, remember the clone. Always keep the clone in mind. Walt McDonald did the seed work and established the viability of seed. Roy Harness was involved with the Aspen Conifer Associations. Norm DeVille had worked on aspen root systems earlier in his career, and then was on the project. And from the DeVille and Winokur work, they talk about fire. Aspen forests also provide protection by acting as living fire breaks for more flammable coniferous types. That Norm and Robert Winokur had the editors. They put together this first synthesis of aspen ecology and management in the western United States, 1985. And for a lot of years, we refer to this as the Aspen book or the Aspen Bible. But this was a great contribution at that time. During this time, Dale was on the project, and Dale was modeling aspen systems and interested in post-fire and post-harvest response to aspen communities. Time management here. Walt Mueller wrote a paper, Age Distribution and Reproduction of Aspen in time. For the region as a whole, 2/3 of the stands are at least 50% or at least 75 years old. So it's talking about the age of the aspen in the Intermountain region, and identifying that the stands were older. Quaking aspen is a relatively short-lived tree, especially when compared to western conifers. Primary studies in northern Utah share observed that aspen reproduction matures in 60 to 80 years, followed by a rapid decline in vigor and increased susceptibility to disease. And there are a lot of issues that Kind and others worked on with diseases. Paul mentions two major considerations determine the management direction required to maintain aspen stands: the status of the aspen conifer succession and the status of aspen regeneration in deteriorating stands. And he said, where stands are over 100 years old and becoming over mature, the tree canopy can be expected to gradually deteriorate. Important concepts that are leading to our decline of aspen. There was as we move into kind of a and also at this time, Wayne Shepherd was working as a silviculturist in Colorado on aspen issues. Kind of moving into the 90s to the present. Don't have much time left, but I'll see what I can do here in this last little bit. There's a document in '94 sustaining our aspen heritage into the 21st century. This is a great little paper done out of the southwestern region. They talked about the decline of aspen in New Mexico from 486,000 acres in '62 to 263,000 acres in 1986, a 24-year period, and nearly a 50% replacement of aspen by conifer or open areas. They make a significant comment: actions to induce suffering must not be initiated before relief from excessive browsing is obtained. This may include temporary actions, such as fencing, removal of some portions of large herbivores from the area, and continued on. In '96, Jeffrey Minton and Michael Grant talk about genetic variation in the natural history of quaking aspen. The most massive known organism, the 66 million kilogram quaking aspen clone we call Pando, highlights remarkable features of the species. So this is where Pando gets named, and it's that basin that's Charles K. and Dale Bartos did an assessment of long-term exposures in ungulate herbivory in Utah. The role of livestock grazing and big game browsing in the decline of aspen in the Intermountain West has long been questioned. And they say, thus, communities dominated by old-age or single-age trees appear to be a product of ungulate browsing, not a biological attribute of aspen, as has been commonly assumed. Aspen, even in the absence of fire and the absence of heavy ungulate pressure, can have multi-aged stems. This single-age stand that we often think about. There was no evidence that climatic variation affected aspen regeneration. Observed differences are attributed to a variety of histories of ungulate herbivory. Wayne Shepherd and Dale and others had the Sustaining Aspen in the Western Landscapes, the symposium proceedings. This is all online, great information, and a lot of significant information. This comes, and it's the work of Wayne and Paul Rogers in the back of the room, Dave Burton of Forest Service, all in California, who gave a tremendous amount of time surrounding the Aspen literature and helping forward. I hope maybe Bobette gets a chance to say a little bit about Bartos, another synthesis paper for the management, the ecology, biodiversity management, and restoration of Aspen in the Sierra Nevadas. For the back page, it talks about researchers that are pursuing Aspen topics. Many of them are here in the room today. Claire. Aspen for about 5 years now. And he wanted to come down and give a presentation. Also, he wanted to do this because of the of a proposal to study the DWR, the Division of Wildlife Resources from Utah, is funding him to do a study of elk herbivory on aspen regeneration. We sent out an invitation internally in the forest into the Dixon and Manti La Salle in December, had it on the 12th of January. Paul was there. We didn't know if we were going to get 15 or 50. We had 70 people show up. There were people there from every district in the 3 districts of Utah. Sam connected with them because he's talking about things that they're observing in the field. He's talking about facilitation of aspen facilitating conifer forests and the way that conifer can interact, the nutrients, the light. Incredible work coming down the line there. And there's all kinds of other things, habitation and sudden aspen decline. And I can see that my time is rapidly gone. There's the fading Aspen Gold video and the fading website. There's the Western Aspen Alliance. There's collaborations going on. There's a lot happening, and I just encourage you to think about that Leopold quote as I started this little 100-year dance through 10 decades, that we need to be thinking about bringing the social and the economic and the histories of things to bear and glean the lessons that we can from those that have gone before. And so that's the summary. This photo is one that Dale put in here. It actually came from the wall. Somebody said, what is a fire scar? And I happened to be looking across the conference room, and this photo was up. It's from the Bentonson Mill fire in 1958 on Beaver Mountain. You see the little island there that got missed by the fire. And this is what that area looked like about 35 or 40 years later. And so it was very serendipitous, and thank you for your attention. I can't imagine going through a history like that, and I appreciate you bearing with me. Best wishes to you, and have a great session here.
Thank you, Bob. We'll have some time for questions in just a little bit, but I think we are going to have to move forward with the program. So our next speaker is going to be Edward Bork from University of Alberta, and he's going to speak about evolving perspectives towards aspen management in grazed rangelands of Alberta. And we'll get